Hey everybody, this is Mr. Walker. Today's topic is, once again, it's multiplication. And the focus today is to multiply 2 and 3 digit numbers. And by that we mean, for example, 58 times 4. 58 would be an example of a 2-digit multiplication problem. So that's what we mean by that. But we're going to be using, for today's video, a traditional method. So let's just jump in. By the end of this video, you will be able to solve problems like these, and again, using a traditional method of multiplication. 58 times 4. Well, remember that 58, if we think of our place value, would be 5 tens and 8 ones. So in a traditional method, we would start with 8 times 4. You could also say 4 times 8. I'm going to show that over here, 8 times 4 and that would equal 32. And we would write that as 32. We would regroup that. And then 4 times 5, or you could also express it as 5 times 4. Would be 20. But because we have the 3 regrouped in the tens, we're going to have to take that 20 and add it. I'm going to show it by putting that up here. So 20 plus 3 would be 23. And so when I write that, my answer would be 232. Or in other words, 58 times 4, the product is 232. And that's using a traditional method or a standard algorithm. That involves regrouping. So I just wanted to just take a minute or two and just explain that. For example, 3 times 3 is equal to 9. And that is a 1 digit. And if I were to put my place value, this would just be, a 1 digit would just be in the ones. However, if I said instead of 3 times 3, 4 times 3, that would be equal to 12, which is a 2 digit. And again, if we look at place value, that would be 1 10 and 2 ones. I purposely highlighted that box in yellow. Remember that when we're doing place value and we're doing multiplication or addition or subtraction, you can only put 1 digit in a place value. So because 12 is a 2 digit, the 1 automatically bumps over to the next highest place value, which in this case is the tens. Now, let's carry 4 times 3 over here. Notice here that we have 24 times 3. And thinking of place value, I would begin with the ones. 4 times 3, well, we said over here that that's going to be 12. But instead of putting the 1 here in the tens like we did on this case, see how we have that 2 in the tens? So the rule is that we're going to have to regroup. And so instead of writing it at the bottom, I write it at the top. So in other words, 4 times 3 is 12. And that 1 is a regrouped number. So that's what we mean by regrouping. And that's the reason why. And then we would go 2 times 3 is 6. You could also say 3 times 2 is 6. And see that number up there? You have to add it. So 6 plus 1 would be 7. So in other words, 24 times 3 would be 72. And this rule of regrouping would apply to other place values. For example, this was a 2-digit problem. In this case, let's just try real quickly a 1, 2, 3-digit problem. So 3 times 3 is 9. That's a 1-digit answer. I did not have to regroup. But 4 times 3, we said before, is 12. Well, I'm not allowed to write 12 here because we have a 4 in the hundreds. So I would regroup like that. And then In the hundreds, 3 times 4 is also 12, and because I've got that 1, I'm going to add that. 12 plus 1 is 13, and so my product would be 1,329. Notice here is a 4-digit, and it's the same idea involved. So the idea here again is that regrouping could be in different place values depending upon the number of digits, and it could actually be in multiple place values. So quickly, 3 times 3 is 9, so I did not have to regroup. 3 times 3 in the tens is also 9. I did not have to regroup, but watch what happens here. 3 times 4 is 12. That's a 2-digit answer. So that's why I had to regroup the 1. And finally, 3 times 4 is also 12. But in this case, I'm going to add it to that regrouped number, and I get 13. So my product in this example would be 13,299. Okay, so let's solve some problems using a traditional method. 26 times 7. I'm going to just drawing this line to show my multiplication over here. Now remember that 26 would be in the tens and ones. Remember, if you're struggling with the multiplication in your ones and tens in your place values, you can use a multiplication chart. It's helpful, and you can find these on many websites. Super Teachers Work, Math Aids websites have multiplication tables like these, and you can also usually make your own. So 6 times 7 I know that's going to be 42, but let me show you why. My first factor is 6 and count down 7. 1, 2, 3, 4, 5, 6, 7 is 42. 42 is a 2-digit answer, so that means I'm going to have to regroup. And now I'm going to do 7 times 2, or you could also say 2 times 7. Either way is fine. 2 times 7, if I use a chart, I know it's going to be 14, but I'll show you why. Here's the 2, and I'm going to count 7. 1, 2, 3, 4, 5, 6, 7. That's going to be 14. And when I show it over here, notice that I have the 4. So I'm going to add it to the 4 that are there. 14 plus 4 would be 18. I'm going to express that down here. So 26 times 7 has a product of 182. 87 times 3. Remember, we're dealing with 2 digits, tens and ones. My first would be in my ones place value, 7 times 3. I know that's going to be 21, but let me show you why. I go to my sevens on my chart and count 1, 2, 3. That would be 21. That is a 2-digit product, so I am going to have to regroup. And now it's going to be 8 times 3. Remember, you're not multiplying the regroup number, you're multiplying the original digit. 8 times 3. I know the answer is going to be 24, but let me show you why. I'm going to start with my 8 and multiply, or 3 hops, 1, 2, 3, so that's 24. That 24 I'm going to have to add to the 2 that are already there. So 24 plus 2 would be 26. So our product of 87 times 3 is 261 using a traditional method. Just 2 more. Let's just go up to a 3-digit problem. Remember, with 3 digits, we are using hundreds, tens, and ones. We're going to start with our ones, 6 times 8. And for time's sake, 6 times 8 is 48. Notice that 48 is a 2-digit answer, so I'm going to have to regroup. Now I'm going to multiply the 8 times the 2, which is in the 10, so 8 times 2. Again, you could use a chart for this, but that would be 16. Now, I'm going to add 16 to the 4. Because I have this over here, I think I'm just going to write this up here. So 16 plus 4 would be 20. Notice that 20 is a 2-digit answer, and you can only put 1 digit, so it's going to be that 0. The 2, we're going to regroup over to the hundreds, okay? Finally, 5 times 8. That would equal 40. And I'm going to add 40 with the 2 that we already had that was regrouped, and that would be 42. So when I write 42, and don't forget your comma, your product would be 4,208. And finally, one more, and again, you can pause if you want to give it a try. Remember that 349 is 3-digit. In other words, we have 300, 4 tens, and 9 ones. We start with our ones, 9 times 7. That would be 63. Notice that 63 is a 2-digit product, so we regroup. 63. Then we go to the tens, 7 times 4, or you could say 4 times 7. And that would be equal to 28. Remember, because we have a 6 up here, we're going to put 28 and add that to the 6. 28 plus 6 would be 34. Now notice that 34 is a 2-digit, and we can only put 1, so it's going to be that 4. The 3 is going to be regrouped over in the hundreds place value. Finally, 3 times 7, which I'm showing over here, is equal to 21. The 21 I can't put here yet. I have to add it to that 3. So 21 plus 3 would be 24. And I don't have any more numbers to worry about to be regrouped, so I write the 24. Don't forget your separator. Our product would be 2,443. Remember that when I'm showing my work over here on the right side, once you feel comfortable doing the traditional method this way, you probably don't have to show these steps. I'm showing it today just so you understand the steps involved. So in review quickly, our lesson today was multiplying 2- and 3-digit numbers using a traditional method of just going by multiplying our place value by place value. And we showed our steps of multiplying our ones and regrouping, multiplying our tens, and adding it to the regroup number. And then when we went to 3 digits, we just repeated that step. All right, well, thanks, everybody, and we'll see you next time.